thanks for having us. I think we're going to be a little bit free and loose with this because, well, I, for one, I've never spoken to a group quite like this, so I want to make sure that you get out of it what you came for. Hopefully, you'll leave with something that you didn't know, especially from Matt, I'm sure, but on the data science part of things, and I'll be talking more on the I/O side of things and how we overlap, cross paths, can work together with data architects, data engineers, and other folks in the organization. And so my background is industrial organizational psychology, and you can advance to that slide actually. So how many of you have heard of it? At least some of you, it seems like, have heard of I/O psychology. Okay, just today? So I/O psychologists are truly scientists and practitioners. I mean, that's what we see ourselves as, at least. And what we do is we scientifically study psychological phenomenon in the workplace. So things like relationships, relationships with your coworkers, with your boss, with upper management, customers, anybody you encounter within the workplace. Looking at individual differences, so differences in personality, differences in cognitive ability, skills, those types of things. We measure those things, come up with good ways, well, we try to come up with good ways to measure those things and turn them into data, and then use that data to make decisions about where people are going to go. Are they going to be hired? Are they going to get promoted? Are they going to join a certain team? Any kind of decision that might be relevant to that sort of data. And we also study things like cognitive processes. So, if I'm interacting with a piece of technology, what kind of processes are going through my head? If I'm reading a resume, for instance, there's a graphic that we were just looking at the other day. Where do you can look at people's eye movements, and where does it go on a resume? How long do they look at that resume? So there's all kinds of data, especially available to us now with technology and the capacity to store all this data. And so I/O has been doing these things, but in a much smaller capacity for a long time. So looking at smaller data sets, looking at smaller subsets of a larger data set, and doing very specific studies on these things. And now that our ability to collect and store and analyze these vast amounts of data, now that we have those capabilities, we're really, I think we're behind the ball a little bit, but we're trying to step in and figure out ways to integrate what we do with data science. A lot of times, and this isn't anything against Matt because I know he's different, but a lot of times a data scientist, they may not understand the context or the data set that they're working with, and or the implications of the findings that they might come up with. So they throw all this data into an algorithm, and then they come up with, hey, cool, look at this thing that I found, and what are we going to do with it now? And then perhaps you're doing something that you shouldn't be doing with it. So we take a very theoretical, rational approach to looking at these data sets, especially when we're dealing with employees, customers, mostly employees, but I don't want to step on anything you want to talk about here. We also work with teams, so project management teams, to work together better when you're implementing new technologies, new processes, change management, those types of roles. My wife does that. Worked with Soch actually at TW Telecom in change management role. She has a degree in I/O psychology. And we also work on things like job design, work structure. Anytime there's a data project, you're getting that data from somewhere, right? And a lot of times it's directly from people. People are data. Like Soylent Green, right? People are data. So I don't remember where I heard that, but I don't think I'll use that again. I got a couple chuckles. So anytime you're gathering and collecting data, you want to think about layering in that people piece. Where do people fall into this? How are we collecting it from them? How are we interacting with the technology? What are we going to do with the data? And so I/Os are well suited to help in those types of circumstances, to help teams work together, to actually do data analysis. A lot of the things I just said, you probably were thinking it sounds a lot like HR. Well, it is like HR, but I think what differentiates us is that we have rigorous training in statistical analysis and data collection and surveying and testing and psychometrics and all of those things where HR generally doesn't get that kind of training. And in fact, a lot of times people end up in HR roles without even intending to. And anybody who gets an IO degree intended to do that. So there is some intense training behind that. And so I had been getting called into, I've been consulting for years in this space, and I've been getting called into a lot of discussions with startups in the HR tech space. So it's folks that don't have an IO background, they don't have an HR background, and all of a sudden they're working with people data, trying to help companies make better software decisions, whatever it might be, without having that background. So they're scraping data from the web, pulling social media data, all kinds of different things together and saying, look at what we found that predicts success in this. But they can't explain why it predicts it sometimes, or in other cases they're saying we need to create some tools, we need your expertise to help us create tests or develop psychologically relevant theoretical processes at least. They come to me before they've gone to that point where they already have data and say, look, it predicts something, now what? I found myself doing that a lot, and I was enjoying it, and a friend of mine that I've known for years wanted to start a mobile first testing company. Basically, not just testing, but any sort of data that can be collected via a mobile device, which it's kind of limitless at this point, if you can figure out how to do it well. And that company's called WorkforceIC. I'm the president and chief scientist right now. He wanted to do it from that IO perspective to build these tools in that regard. So he came to me at the beginning. And so we've developed some tools to use in the screening process for hiring new employees right now. Those tools are for customer-facing, hourly types of positions, but that's just because that was who was interested at the time. We're planning to build additional tools as demand comes in. So, but that's a little bit about my research background, I guess. So, test development, measurement development, psychometrics, and then also performance measurement and feedback within organizations. So I also work with a tool called ProMes, a productivity measurement and enhancement system. It parallels Agile, but it's broader. So it's why are we here? Why do we exist? It's not, for a project. It's why do we exist as a department, as a group, as a unit, and then figuring out those objectives and how we're going to measure that, and then building systems for delivering feedback on whether or not we're doing it. So I have a lot of research in that space. So I talked a lot. Sorry, Matt. I'm sorry. You can hit the next slide.
You're good. Yeah. So my background, a little bit interesting in regards to data science. So I was also in a PhD in industrial organizational psychology at Virginia Tech. A lot of my research was on leadership and motivation initially, but then I started segueing a lot more into methodological issues. So there's quantitative methodologies, especially something called social network analysis, which looks at sets relationships between generally people, and what you'll good example would be informal networks that aren't created by a corporate hierarchy. You'll find that perhaps like the secretary Karen is the information domain expert in regards to so many processes, and so you'll see that she's a key member, a star, or a bridge for communication between people. And so you can start identifying like individuals that are really important to an organization, or even if you're doing, this is an IT crowd, so we're not actually doing like marketing or something, but if you wanted to do targeted marketing on Twitter, that was one of the things I worked on with Sports Authority, was essentially developing and giving free products to those key stakeholders in the Twitterverse so that they could disseminate promotion of technologies and tools. And then, so I left before I finished my PhD, tried to save Sports Authority, could not. Interesting case with them though, I did customer segmentation for them, which is trying to identify similarities of different customer segments or groups. And what I found is the consulting firm that had done this years ago had done it wrong. So Sports Alert even targeted marketing the wrong people for 7 years. Executives weren't really happy when I told them that, but it happened. Worked with Dish in regards to their big data. They have 4.5 petabytes of data. If you still have a satellite box, anytime you press channel up, down, pause it, all that's recorded. So there's a ton of information that you can gather in regards to how people operate. I guess, semi-interesting thing for me in regards to coming into data science is about 50% of data scientists come from a computer science background. That's why you see a lot of data scientists use Python. The other 50% usually come from hard sciences, so physics, biochem, etc. And those hard sciences generally leverage the R. So both open source tools, so people are starting to segue away from SPSS and SAS, legacy software that's really expensive. And so yeah, mine was interesting because instead of taking a programmatic approach or a pure quantitative approach, I wanted to take a human element approach. So my background's in psychology and sociology, so I wanted to understand, why people do what they do, and it's based on both their, intrinsic motivations as well as their external influencers. So that's how I've applied these methodologies, and so a year ago I started a data science consulting firm, and it's gone really well. So it was Summit Analytics. Now the new company, I just formed a partnership with the former co-founder of Slalom Consulting, and we have a C-suite from one of the 3 top tech firms in the world as our advisor. So we're making pretty good progress, and yeah, I guess in regards to what is data science.
Hey Matt, can you tell us the name of your new firm?
Have, H-A-A-V-E. So it's Finnish. Nora and Nora's like full Finnish. I'm actually partially Finnish. So it means vision and to inspire. So our goal is essentially to have and my approach also with data science is a little bit different, and our presentation is a little bit shorter so we can leave time for a lot of Q&A. But we see a lot of data scientists or a lot of companies kind of spinning their wheels in regards to, they've collected all this data, but they don't know what to do with it. Our premise is that we want to leverage data for strategic initiatives, for actionable results, instead of just building a model and saying, this is what it is. Yeah, vision and to inspire is because we care about our employees a lot. So I want to let them continuously grow and train, because data science is not a stagnant field. The tools, technologies, which you guys will see in the landscape later, as well as the methodologies, are continuously adapting. Okay, so with that said, how would any of you define data science in regards to your interpretation of it right now?
I mean, to me, it's just mostly, you have a data set, you apply some algorithm to it, and learn something from it.
Okay. Yeah, so data science has a number of definitions. I still haven't found one that's good or great. The most common one was it's a computer programmer who's better at statistics than other computer programmers, and a statistician that's better at programming than other statisticians. But I feel like there's so much more to data science, because you have to understand the importance of the data being collected, the cleanliness of that data, the statistical anomalies that can occur in that process, and how it's going to be leveraged. And so I don't think it's just a pure computer science problem or pure statistics problem, but it's really a business domain problem. And actually, I guess we can move to the next slide. So one of the most common methodologies is called CRISDM. I haven't looked at that in a while. Cross-reference industry standard. Don't have it on the book.
I didn't put it on there.
It's on Wikipedia. No.
Protocol.
Data management. So it's
So the one word you haven't said yet is analytics, though.
Yep.
I didn't want to go out on the limb. I let him do it on the
Yeah.
your last question.
Yeah.
But at CDOT, we have so many different data sets, a lot of them overlap. That
Yeah.
We've stood up a chief data office,
Yeah.
not an officer. And it really is more about the data science or the analytics.
Yeah.
But it's to use the data to help determine how to design roads so that if a road traditionally has a higher quantity of traffic accidents, don't design another road like that.
Sure.
So, you know.
Yeah.
So I don't know if that plays into the answer too.
Yeah. Yeah, I guess we're gonna get into data integrity and whatnot. So yeah, it will. And so in regards to this model, this is the most common methodology. Supposedly 70% of companies basically use this, whether they know it or not. But one of the, I think, important components, which we'll get into a bit throughout this process, is that, you know, a lot of us being in an IT space, we often have a really good data understanding of what's in the warehouse or what we're collecting, but we don't know why or how it's being leveraged. And so one of the things I've seen at a variety of organizations is the different domains, the different departments between business understanding and data understanding aren't communicating, right? So marketing or HR may need specific data for to build models to ensure the accuracy of those models and be successful. But for some reason we're not collecting those because there's miscommunication or a communication barrier. But what should happen is essentially that we should understand from a business perspective what problems we're trying to solve, right? So customer churn, employee churn, segmentation, recommender systems. And from there, look at what data we're currently collecting, look at what data we could be collecting, so that we can answer those types of questions. From there, we move into data prep, which is going to be a lot of the cleaning process, visualizations and exploration for data scientists. About 60 to 80% of time is actually spent in that process. So if you're a data architect or engineer and you can actually facilitate in the cleanliness of the data at onset, a data scientist can build a lot more models, be successful much faster. Because until the data prep's done, data scientists can't go into modeling. Or you'll see that there's a lot of people with the data scientist title right now who don't have any quantitative background. They've never taken a statistics class, which is highly dangerous, right? And there's a company that's also promoting it. Has anybody heard of Data Robot before? Mm-hmm. Okay. So Data Robot, if they were promoting it as a tool for data scientists to leverage, I wouldn't have an issue with it. And I have lots of friends that work there, but they target it for data analysts. And one of the things I've said is that they basically say that you can just throw all the data in and it'll run thousands of models with various hyperparameter tuning and then give you the best results. Well, if the data being fed in is inaccurate, right? Let's say all of New York sales were encoded as California, then all of our marketing strategies, all of our product development based on location, the models are going to be completely erroneous. So what's really important to know is that the data is actually accurate before you go into that modeling process. From there, there's various ways that we evaluate those models. And then depending on if it's front end or back end, we get into the deployment aspects. Yeah, I think that's a decent start for data science.
You're gonna go to the next one. I think you kind of hit
Yeah.
on that a little bit.
Yeah, so just in regards to the actual process, so the way that all this starts, and my opinion, my promotion, especially to various startups, is that they should get a data scientist as early as possible to understand what data should be collected so they can build models to answer questions in the future, right? So if a data scientist is working with a data architect, then they can design the ecosystem appropriately. Snowflake star schema, and looking at all those API ingestions to ensure that the data is coming in as clean as possible, as fast as possible. The engineer obviously going to do a lot of those APIs and data ingestion, hopefully a lot of the data cleaning. And then after all that's done, a data scientist is accessing that data. Whereas a data engineer, like the New York, California thing, a data engineer may look for something like that and say, oh, there's no New York sales this week, something might be wrong. A data scientist is going in and saying, there's anomalies with this data, there's outliers, the distribution's wrong, those kinds of things. So in regards to data cleaning, there's different aspects to how data engineers focus on in regards to cleaning and what data scientists focus on.
This is what we were talking about avoiding. Throwing all the data into a black box and seeing what sticks, what comes out, and not being able to explain that. And you have any more to say on that?
This is something I've specifically been asked to do like 10 times here. It's like, can't you just throw it on a thing and it'll tell you?
Yeah.
It helps to have a
And
question in mind.
that's I think part of your complaint. with
Yeah. So a lot of even the MOOCs and the boot camps, the machine learning algorithms basically say you can throw everything in. But what one of the important things to assess is actually if predictors, the variables you put into the model to predict what's going to, or classify what's going to happen, that if they're highly correlated, it's going to cause issues with the data in regards to which features are actually important. So spaghetti of the wall can be dangerous, although it still, kind of operates in a oil water stack where the top features will end up rising, but their actual relevance may be wrong depending on if the data is clean, if the predictors aren't correlated with things.
So would you guys say this is a misconception that you're fighting out there? Do you see this? Do you see people intentionally trying to do this, or maybe just accidentally do it?
I think it's both, but I think there's definitely people don't have a theory of the firm or a theory of what's going on, so they just take, because it's there, they throw every single piece of data into the model possible.
So do you find that a reason for that is there's no alignment between business and the tech side of the business, where we're collecting data and we don't know why we're collecting it?
Yep.
That's some
Right,
probably
and so solving that problem is your kind of psychology side of things, right, in terms of business alignment with.
Some of it really is a marketing problem for data science tools, where they go tell your executives that, no, all I got to do is throw all this stuff in here and we'll tell you, and that's not really the case. Kind of like
just hit the easy button, just give me the answer.
We even did this with like web-click data, and we found like someone who used like a certain type of browser bought more mutual funds. Like, what the hell are we going to do with that? That really means nothing. But they're, hey,
Compared to what, right?
And all that was the base rate for whatever the browser population was. So,
Just get more people to that browser.
so, I've fought against this. This comes up a lot, and a lot of it is because some executive will watch a 10-minute seminar of a guy dumped a bunch of crap into Mongo, and ta-da! Look at what we found. And,
We gotta have that.
Yeah.
It came out green with an up arrow.
Yeah.
Well, the fact that you're fighting that's good. Because that's what you need to do is push back. Why are we doing this?
Yeah.
What's the business question that we're trying to find?
That's still, I think, the hardest problem in all of this is I yet at least to see here a really good question be asked. We're still kind of in data gathering phase. We're putting stuff together that we know is important. We're a big old company. Data's all over the place. So stitching that together to at least be able to flatten out and do something with it is important. But
Yeah.
still haven't seen a great question.
Yeah. Well, and if you haven't seen the great question, you don't want to spend all the time trying to integrate the data.
Yeah.
So we're already talking about this right here. He talked about it from the CRISP model, but this is the scientific method that we're talking about right here. So it's defining that question, it's getting the right data, or researching, do we have the right data to answer that question, forming hypotheses, and then actually using that data or collecting additional data if we need it, analyzing that data, and then drawing conclusions, hopefully drawing conclusions that can help you make better decisions about your people, about your processes, about your marketing, whatever it might be. And so it's important to get communities of interest, I guess, together within organizations, that, if there's folks from the marketing team that have an interest in data, in data science, from HR, hopefully you can get a community of interest together and to start talking about, what it is that they need to be coming to you with and what they shouldn't be coming to you with, perhaps. What it takes to actually, do the type of work that they're asking you to do in some cases, so they understand the complexities of the data, they understand data quality issues, they understand, you know, what you're asking me to do. There's a ton of missing data, so we're gonna have white spaces in our algorithms, and we're gonna have all kinds of issues. So if you can get those conversations going with people, you can start educating them a little bit. They can educate you a little bit on what are they doing over there that they came to me with this question. Was it somebody up above that came down and said, hey, go find this out from our data architect or data engineer. Go ask them to do this, or see if we can find this. And they probably never asked that person, okay, well, why are we looking at that? Or, you know, what is it that sparked that? Do you agree with that?
Yeah.
So getting those communities together to talk, to network, can help everybody get a greater context for the business needs, and also, you know, from what do we need to ask and question-wise, and also what kind of data do we need to answer those questions.
Does anybody remember, I guess in high school, p-value? Yeah, maybe? Okay. So 0.05 was the standard. And so one of the interesting things, which is why a hypothesis-driven approach in regards to the variables you put into a model is really important compared to spaghetti the wall, is that the way that a p-value of 0.05 equates out, it means that essentially for every 20 variables, 20 predictors you put into a model, one of those is going to be spuriously significant, right? So it means it's not actually a significant variable, but just due to chance alone, it emerges or shows itself as significant. And so if you put 500, 10,000 variables in a model, you're going to get a lot of features that aren't actually true predictors that are actually driving those results, but it's spurious. And so if you actually take a hypothesis-driven approach in regards to, why do people act the way they do, or what products should we recommend or anything like that, it makes things a lot better because you're taking that scientific approach.
It looked great on the training set, though.
So you mentioned a spurious correlation earlier. You just talked about it as a good segue. Here's a fun one. There's a Tyler Vegan has a whole book on these spurious correlations. You can just Google it. There's so many funny ones that I had a hard time picking, but Nick Cage is always a good joke. So, but yeah, there's a strong correlation between these two things, but there's really no reason for it, right? It's just purely coincidental. And there may be, I doubt there's even a third variable that's causing this.
How many people did that while watching the film? How many people? I wanted to go drown in the
Because they watched the film.
Well, maybe okay, you've explained it. All right.
Yeah.
We can take
People
that out
paid
of
for
the-
movie tickets, and then, yeah.
We'll tell Tyler to take that out of the
Yeah.
book.
So you can put the suicide variable in there too after watching it.
That's what I was implying, yeah.
How do you determine that it's random though? Because I mean, this is an obvious example, but in the browser example, my first thought from a UX perspective is there's probably a correlation between browser choice and demographic information.
I was actually thinking wealth, and probably Safari was the highest.
Yeah, it was some
sophistication.
crappy Windows one because most of our sales are done through financial advisors selling to people. We don't really know who the actual anything of demographic about the shareholder, but we know guys sitting in an office are all using the same base version of Windows, and we can tie that really well to which firm they're at.
Right.
So if it's Netscape, it's old money versus new money.
Yeah.
Hit that mute button. Right, but my question is that if that's not as obvious, I mean that's a great.
But that
insight.
required knowing the data there. So
Yeah.
on the surface, it seemed like, holy cow, we have something, and we don't actually, because
Right.
someone sitting in an office with their 9-to-5 day job is placing trades on behalf of hundreds and hundreds of people, and we don't really know anything about
Right.
it. But at first pass, woohoo, we have something.
Right.
But if you can't influence the variable, maybe it's not so important to have in your model.
Right. Yeah, it's just dangerous to dismiss it up front without coming to that conclusion and due diligence.
I completely agree with that. Yeah, in knowing the data is how you're going to know if it's a spurious
Right.
correlation. Yeah.
Chicken and the egg, right.
We're understanding,
Yeah.
is there a third variable here that might be causing this that we haven't
Right.
considered? If you know the data, or you know the business context from where that data came, then that's how you can decipher. Yeah, the ones that he has are just ridiculous, but they're fun.
Right, oh yeah, for sure.
What if you don't know the data, or you don't know much about the data, you just have a huge set of data, how would you eliminate things that are not, that are actually not valuable features in your data set, if you don't really understand your data?
I think some of it will come down to practicality, some of it comes down to talking with people that might know the data better. There's probably statistical techniques that,
Yeah, I mean,
I guess that's what I'm more.
Yeah, I mean,
If you don't know what the data is, how can you eliminate it?
yeah, I mean, feature variable wise, there's certain things. So if there's no variance, if there's no variety in the data, if everybody's a one, then obviously it's not going to be important because it's not differentiated. You need variance. If 99% of data is missing, it's not a good predictor because even if it's included in the model, it's still going to be bad. And yeah, I mean, like variance inflation factor, there's variance statistical techniques, but again, I mean, that's why, essentially we try to focus on a hypothesis-driven approach. So one of the things I didn't talk about in regards to data science is that, with our consulting firm, we work in every, so the methodologies, techniques are the same across industries, across departments. The only thing that's a differentiator is domain expertise. So you have to have that knowledge to be able to essentially predict. I mean, you can still build a model and you can still get X amount accuracy, and it's still probably better than off the cuff. But if you have domain knowledge, if you know like that, okay, well, young hipsters tend to buy Apple products, and so obviously that demographic's going to be younger. So if you were to try to predict, or even like the browser, right? So if you're trying to predict browser usage, well, it's likely that, because Safari comes native to Apple, that it's going to be young people as will be a strong predictor in regards to if you're using Safari or not.
But then do you put bias into your data set by doing that? If because maybe that's based on your experience, it's a subset of experiences, so you could be, biased by data unintentionally.
Yeah, so I think it gets at the, what was the common example we used when we taught ice cream and murder rates, right?
Murder rates,
yeah. So, like, you see that increase and you wonder, well, does eating ice cream cause you to murder people? But it's just, it's actually a dualistic latent feature. One, murders occur more in the summer and people are out more in the summer. And so that's, I guess, where that domain or people understanding ends up being really relevant, because if you can say, oh, there's probably something that's driving that. It's not just that, people kill themselves because they see Nicolas Cage movies. It's that maybe his movies are released more often in the summer or whatever. It makes things easier.
There's also a dirty trick on this though, where there's two y-axes. 2, 4, 6, right? So that's a dirty trick.
Yeah, like magnitudes.
Tricking you with data visualization there.
Yeah. Okay, well, but then something like ice cream and murders, maybe it's actually valuable information that ice cream sales are going up, because that could indicate that there's going to be more murders. If you don't know that it's, if you don't know that it's summer, if you don't know it's seasonal.
Even though you haven't proven
Well,
the actual correlation, right, it is still predicted. Right,
So, accuracy, if we're just doing R squared, is on 0 to 1, and usually and the higher the correlation, the greater the accuracy there.
And even this, when they release movies, they look at the market and they, as far as timing, and there could be something going on, in society, or, something that's happening in the way that people are viewing things that make it more likely to release Nicolas Cage, and I don't know, let their kids play dangerously around the pool. It's like,
Well, yeah, and so so let's say finance, right? Let's say I built a model with a ton of stock data, and I got an accuracy of 0.5. Well, that means that I can explain 50% of the variance, so I can 50% of the time accurately predict whether stock's going to go up or down. But let's say then I think, well, maybe weather's an influencer or social media. So then I start, aggregating these other sources, and then the accuracy increases to 0.75. Well, I just increased the accuracy 25%, or I guess more than that. But, and that's because, you know, essentially we're including more and more features that are relevant. If you included something that isn't relevant, like the amount of coffee you drink per day or something, then the factor won't emerge as significant, and so it can be dropped from the model.
Okay, so yeah, that's one way too, right? You can like add and subtract
Yep.
features until you get to the best performance.
Yeah, I mean, before machine learning exists, the most common methodology was stepwise regression, which is adding a variable and seeing if the accuracy
Yeah.
increases each time.
So how do you go about figuring out what data sets to grab? Right? Because you can ask a question, why are the murder rates going up, right? But then you have to come up with a data set to kind of give you that, you know, help figure out what that cause is, right? I mean, you could go look at movies, you could go look at coffee, you could go look at summertime or seasons, right? But how do you figure out which data set you want to pull in that would help you to correlate that question? That
That
seems to
particular
me.
question, I'm not sure, but, but the general approach would be, first identifying I would first start with what data do we have, and is it measured at the right level? Or is it at the type of scale that we can use? Did they use an appropriate scale? So if it's like age data or something like that, do we have it on a continuous scale, or do they bust it down into categories? And will those categories give us the information we want if we're trying to predict something of that age? Probably come up with some more stuff, but it's really looking at the veracity of the data, looking at the level that the data had been collected at. Is it going to answer the question? If not, do we need to figure out a way to parse the data? Is it there, but it needs to be parsed? And maybe I'm not answering your question here, but because it's a big question. It's a big question.
Yeah, I can give an example. Has anybody heard of Sling TV?
Mm-hmm.
Okay. So I did all the analytics a few years ago for them, and it was when it first came out. And what I found was that it was about 35% churn rate over 90 days, right? Which is really terrible. They were still growing because so many people were buying it, but you're losing a lot of customers month over month. And so I went into the Sling TV data, see what's collected there. And so, you know, it was the channel that the individual's watching, if there were any buffering milliseconds, the length of time they watched. There were only about 10 variables being collected right then. So I tried to predict a model whether customers were likely to churn based on these features that are in this data set. And the accuracy was only like 0.4, 0.5. And so then I went and looked at everyone who dropped, looked at why they said they left. So I did text analysis and topic modeling to understand what features were driving that. And a lot of people were really complaining about the user experience. So like from a methodological standpoint, you know, it wasn't heavy quantitative initially because I could just go tell Sling TV, you guys need to fix the user experience because this is terrible, right? You have 80% of your customers complaining about it. But then, you know, also gave recommendations in regards to what other data they should be collecting, which was me, you know, going on to Sling TV, trying to watch shows, trying to see what it was like, to understand like what it's like for the customer to use that platform. And so then gave recommendations in regards to what other data should start being collected, because there are like hundreds of features that can be. And so one of my new hires, I had worked with him at this years ago, and he just redid the churn models for Sling TV. And with all these new variables, the accuracy for predicting churn was now 91%. So I think it's really just taking that, you know, as long as you're working, and most of us do work, you know, latently or directly with humans, understanding like the processes and mechanisms for why they do what they do, and what it's like for them will allow us to try to understand what data should be collected. So I always take the approach of, you know, getting my feet into, you know, someone else's shoes and understanding, you know, what their experience would be like and what they'd be thinking about in that process, and then thinking about the variables that you know, may be relevant, that may drive those predictions or classifications.
And that's why I think the IO psychology part of that is important.
Yeah.
Right, because if you go out and get that additional data set through some type of psychology, right? Then you can understand maybe why some of that's happening and raise your accuracy quite a
Yeah,
bit.
no, I mean, there's, so a lot of, I think they're getting better. A lot of the IO psych schools, we're still using like SAS and SPSS. So most IO psychologists aren't programmers, but any that do use R Python, like I definitely willingly hire because they take that approach, that scientific approach in understanding people before getting into the programming aspect.
Okay, you also mentioned that a lot of the data sciences either come out of technology or come out of the sciences itself. And yet, like I have a degree in industrial psychology. It seems like this is ripe for, you use the word psychology, but you haven't said psychologist. It seems like this field is ripe for psychologists if you can get them in there.
Yeah.
Absolutely.
Yeah.
But right now,
no,
there's
I mean
not a
that's
big-
what that's what I think the goal is, and I mean so PSYOP, like there's been recent talks that they need to change essentially their teaching curriculum, that it focuses more on machine learning, that focuses more on programming, because IO psychologists can be absolutely stellar in this if they get that experience.
We're seeing it at the annual conference every year, it seems like the number of sessions on data science doubles, and the people coming in aren't IOs necessarily, they're people from the data science world, the programmers,
And it's even at the high school level. I had two students, I'm on a teacher advisory committee, and two students out of Green Mountain High School came to me because they want to be, data scientists. And so it's not even at the college level now, it's getting down into the high school level. These kids are pursuing that as a career.
So, a question about kind of incorporating that behavioral piece into, other types of problems. Like so we're trying to figure out how likely it is a loan will default, and so we're looking at all basic things that you would think of, like balance and interest rate and all that stuff, credit. But we've talked about incorporating like some personality profile type of questions also. So how would you go about, you're starting with basically no data at all. So how would you go about trying to identify the best questions to incorporate in something like that?
And like, are you guys pushing out a survey, or are you just looking for other data sources to ingest?
Well, we could potentially push out a survey to, like a set of property owners that we identify, and try to get them to answer these questions, and then we can look at the defaults in that data set. That'd be, I guess one way we can do it, but that wasn't, we don't really have a plan for it right now.
Yeah, so I guess I can do one then, if you have one. So yeah, like when I did segmentation at Sports Authority, we initially pushed out a 4,000 person survey that we had developed to a nationally representative sporting goods sample, because I was doing a SWOT and gap analysis along with the segmentation. And so we did that, and then we also, Sports Authority had 45 million people in the database. So pushed out this survey to a nationally representative sample, tons of questions, both in regards to just lifestyle, sporting, what you drive, everything, political affiliation, everything you think of. And then on our internal database, we had a lot of their transactional data, but we, I guess, increase the depth of it by ingesting Experian and Epsilon data. So you get a lot of customer personas, you get credit card information, and all these other aspects. And so our approach, I guess, was both. We found that pushing out surveys ended up being really useful because you understand the why mechanisms of things, because a lot of times data warehouses are just transactional. But same token, you can't always just pull 45 million people in your database and expect them to fill out a 300 question survey. And so based on that, Experian Epsilon, like proxying that data, allows us to identify if the clusters are similar.
Right. Yeah. Actually, to your question, I used to work for Sling TV as well.
Yeah.
And that qualitative in-person aspect is so important. So one of the things that they discovered was they're dealing with a lot of fraud. People that are actually just stealing streams from live TV. And so they found out that Middle Eastern people that moved to the United States are very prone to doing fraud and actually cheating with Sling TV.
Yeah.
And it's a really hard market to target because if after interviewing people, they found out that in the Middle East, all TV is available for free, and it's a really weird concept for them to actually pay a subscription to receive TV. So, but again, the data alone will just give you numbers. You actually have to go talk and do some a little more qualitative research to actually figure out, okay, now that makes sense.
Well, and I think, Brandon, you can talk to this, and Ryan, I think we've had discussions around this as well. Like, I think you need to be aware sometimes where the data leads you could be a very slippery slope, right? So while you may be able to draw like some kind of, not really, some kind of correlation, if that correlation tells you that, hey, we need to discriminate against this ethnicity or this gender or this background, like, that could be problematic.
Right. That was the first thing we did, is eliminate all that kind of data from the set, just so that we would know, like sex, race, all that pulled right out.
Yeah, well, and you said it, I mean,
Still.
it comes down
You
to.
might still be discriminating.
Not only legal issues, because what you're talking about are, that kind of discrimination is legal issues, but, and even if you pull out things like sex and race, there may be other things that are related to those. So like, let's say you have some bio data, and it's like, I like to go fishing. Well, it's probably gonna be heavily male, and you find out that people who like to go fishing are better at paying their loans. And now, you're heavily loaning to males versus females, and so there's some bias in there in the loan. So there's that kind of thing you have to be aware of, and then, but not only the legal issues, but what are the effects of using that information, and are you willing to, if it did come to a legal thing, are you willing to defend it in a court of law? Are you comfortable telling somebody you're not getting a loan because of X, Y, or Z? So you have to think about all of those things when you're developing those types of instruments or.
Yeah, that's what you say, I'm just a data scientist talking to the attorney.
Yeah, and you can't just erroneously throw away data. I know, so for Sling, I just remembered I did geolocation mapping because Sling TV is only accessible for the U.S. and was presenting it to, I guess, the VP before it was going to the execs, and geolocation mapped the entire world, and there were people like all over using it because they were VPNing in or their family was sending the access, and they're like, no, delete this slide, we can't have it. And they're like, delete all that data too, so.
And in our defense, Amaresh and myself, we pay for all of our team. I get that out there.
The phishing example is interesting. I used to work for policy studies. You can use that data for good reasons too. So they found that the strongest incentive for people who are not paying child support in certain states is to take away their fishing license.
Really?
And so, yeah. And so they, you apply for a fishing license. They do a check if you pay child support, and if you can't get it, it's the most effective way.
We
to
do that in
enforce it.
Colorado.
Oh, okay.
Really?
Yeah, we do that in Colorado. If you're behind in child support and you go to Parks and Wildlife and try to get a fishing license, it doesn't happen.
Right.
That's why that's good.
Hard out there.
Wow.
Now you know, just think all the things you could do with fishing license.
Right. It's just using that data to find your leverage.
Yeah.
Find out they're gonna be more effective than like correctional facilities or
Never
something.
speed again.
Yeah.
But
All right,
on
so-
that point too, there's a lot of stuff on social media. I was looking at one product for lawyers to do jury selection, and they would put in a name, phone number, address, and I think it was a company called Full Contact.
Yeah, I just saw an ad from them this morning.
Yeah.
Like that.
That's a Colorado company.
Yeah.
Yeah, so
Or
Full
outlaw.
Contact pulls social media and then rates people on like political affiliation and everything. So a lawyer can just look up everyone and say, okay, this person's on the left, so I'm gonna get rid of them for whatever reason. So that kind of stuff is out there.
Yeah.
And
Well,
that's,
it's the same type of thing happened
But-
in the election.
Yeah. Read the Vice article on Cambridge Analytica.
Mhm.
It's long, but it's really good.
All right, well, I think we've hit on a number of the things in these next few slides, but.
Yeah.
Talk about that one.
So yeah, just really briefly on this one, and then we'll actually get into the data issues. So, you know, anybody that's an architect's probably heard of the 3 V's, but volume, variety, velocity. So these are things that we have to focus on. Obviously, you know, from a data science perspective, data volume that are in, you know, petabytes, exabytes, obviously can't be processed on, you know, even the servers. So you have to use different techniques like subsampling, proxying, things like that. Data variety also is important to data science, so a lot of the machine learning algorithms are primarily based on structured data, whereas the things like neural nets, if you've heard of those, actually leverage or are leveraged for videos, pictures, and text analysis. And then the last thing we often focus on is data velocity. So whether we're doing, you know, batch processing of just new customers coming in and running something once a day, or we need to do real-time streaming to, you know, recommend a product immediately to someone based on a website they visited.
And we just hit on a lot of this through our discussion just now and previously as well. So it's really important when we're dealing with people data, especially, that we think about the integrity of the data, but also how we're using the data. So think about legal and ethical considerations that we were just talking about. So I'm adding 2 more V's. Really, what are the values that you hold in your organization, and think about those values when you're using that data, and how you're using it, how you're storing it, you know, security, all of those things. Are you being transparent when you're collecting that data? Is there an option to opt out in some cases? Or in Europe now, I don't know if it was before, but especially they just overhauled things, yeah. And you can just erase yourself from a database, no questions asked. I know that I've tried to erase myself from things here, and it doesn't happen. And if that doesn't happen there, you're fined. I don't know. It's a huge fine. I think $20 million is the minimum for any kind of a breach like that. Thinking about sometimes a data set is okay on its own, but the second you link it with another data set, now are you re-identifying somebody who is anonymized? That type of thing you have to consider. And then just the big thing is, you know, the veracity of your data, which we've been talking about a lot. Is it a complete data set? How much is missing? Is it clean? And as an IO psychologist, the first thing we do is clean the data set if it wasn't clean when it came in. And a lot of times these data sets that I've come across in organizations, you've come across them, I'm sure, a lot more, have not been touched, have not been cleaned, have not been thought about until that question is asked, and then they want you to do it. Sometimes you can run the analysis and find out what needs to be cleaned, but yeah, making sure you have good data going in, garbage in, garbage out, and that's exactly what I'm getting at there. Large samples, we always think they're more representative, but not necessarily. Generally going to be more representative than small psychology studies done on a university campus, but which is a whole different issue and presentation probably. But they're not necessarily representative, so you have to think about that kind of thing. And then the appropriateness of the interpretations you make based on that data is a huge issue. I think we've hit everything on there. Talked about impact of data-driven decisions, using that, you know, some of that human judgment about, even though the data says this, is this something we should do? And cyber threats and breaches are, again, a whole nother ball of wax. But, you know, just thinking about people data, HIPAA requirements, things like that, healthcare, health information within organizations. Was $140 per case of breach. Is that something? I think that's
it's something that gets
an astronomical
It's
amount.
more than that. Yeah.
It's more than that?
Yeah.
Okay.
Yeah. I mean, yeah, you get into PII and PHI data, and you know, who has access to that, because certain people, you know, like especially from an HR perspective, aren't allowed to see that. But if everything's in the same warehouse and you don't have filters set up for user access, then it can be really problematic.
And then, like I said, in Europe, it's even more strict.
Yeah.
And so
did that come from the data director in the European Union? Is that a regulatory requirement? How's that?
Yeah, I don't remember how it was passed down.
I know UK had it for a couple of years, but maybe EU has it now too.
Yeah, the EU passed it like 2 years ago.
Okay.
Like that.
Yeah. So those are things to consider if you're international or using international data,
So-
integrating international data.
So an American Fortune 50 company domiciled here, they have data on a European citizen, they have to do that as well.
Yeah, there are lengths that you can hold the data. I mean, there are all kinds of requirements that we don't have here.
Yeah, and then just in regards to you know, how we build these models and evaluate them. So we started out what's called a parsimonious approach. So what we want to do is build a model that's, we'll say, as simplistic as possible. So if you've heard of linear or logistic regression, linear regression is used for prediction. So your outcome variable is a continuous number, and classification problems are categorical. So we'll start there, but often the accuracy isn't as strong compared to using some of the more advanced machine learning methodologies, so support vector machines, multi-adaptive regressive splines, cubist models, random forest, gradient boosted models, XGBoost, and then it ultimately gets into the neural networks, which essentially the way they operate is that they have what's called hidden layers. They're basically the same thing as latent features in psychology, but you know, there's a B2B client I'm working with, and they found you know, that the likelihood of a sale, one of the primary features is a user's title or an employee's title, and you can think, yeah, that makes sense, but really is getting at the fact that, you know, VPs and C-suite individuals have a lot more influence or decision power, and they also control the pocket strings. So those are like hidden features that obviously aren't collected, but when you actually, you know, think about that process, that's what's actually driving likelihood of a sale closing. You or me?
Go for it.
So yeah, if anybody wants to look this up, Matt Turk, Turck, he's been doing this since 2013. It's called the Big Data Landscape. And the nice piece that he's done is essentially shown, and it's so small here, all of the tools and technologies that are being leveraged in the, I guess the entire infrastructure space. Not necessarily the full stack, but anywhere from the data warehousing through the analytics, BI tools, etc. If your organization is nimble, if you do download this, you'll want to go to the green area because it's open source. So most of the good data scientists are using those types of tools like Spark, H2O, using one of the Apache Hadoop framework, etc.
And so I think we've been talking about this a little bit again, but this is, you know, when the type of work I do with WorkforceIC, we're developing instruments to make better selection decisions, and what it boils down to is we want to save costs because we're getting people who are absent, we're getting people who are tardy, we get people who leave right away. They're not performing, so we're trying to build or find data that helps us predict whether or not, or predict production rates, error rates, those types of things. And so I just wanted to put a quick model of kind of how we go, but these are just kind of buckets of input variables, the proximal variable that we're trying to predict, and then how it impacts the business outcome. So it's cost savings because we don't have as high a turnover, or it's increased revenue because we have better salespeople, whatever it might be. And you can flip to the next one. And what we bump into is that we need other data to make sure that our tools are actually predicting. And so this is just kind of a framework for the different types of human capital management systems that are out there. And so we find, you know, companies have all sorts of different stacks. You can't go into a large company and expect that they have this set of tools, and then this size company they have this set of tools. It's all over the board, and so we have to try to find data where we can find data right now. Our goal is to build additional tools so we can collect that data and don't have to worry about talking to all these different systems every time we need some performance data or some data for our predictive models. And at some point, we can have a streaming validation process, so our model's continually looking at the types of data we're collecting, and are they predicting whether people are learning in the onboarding experience, are they enjoying their new manager, 3, 6, 12 months down the road, how are things checking in, how are things still going, getting that performance data. We're working with a company right now that installs the kiosks at restaurants where you can order. All the POS data is on there. We can integrate our surveys software to do quick customer satisfaction surveys and pop out a coupon for somebody. So we're trying to integrate all of that kind of data to get that hard performance data to help with our models. We can go to the next one. And this is just the subset of the slide that he was just showing. And there's just way too many tools out there in just the human capital space. But then human capital tools need to be talking to tools in finance, marketing, and sales. And that really becomes difficult. It's difficult just with the silos of data within HR, but then to try to get finance to share data and have our systems talk to them, or sales, it's quite difficult. So those are all the types of things you need to think about when the question comes up that we want to know the answer to this. Well, where are all these data pieces? And they're just talking about the data that they have in marketing. Well, is there something over here in finance, or something over here in sales, or in HR that we can pull from that might provide us with better answers? Simon.
Oh, okay. Yeah, so essentially there's 2 ways data science models are deployed. One is that it's model interpretation for strategic decisions, right? So if it's the customer segmentation from a business strategic marketing perspective, then you just want to know what those personas tend to look like and how you're going to market to them. On the other hand, you can have things built into the back end. So, once a user comes in and makes a purchase, they can automatically be clustered into a specific group on that back end of the ecosystem, and then automatically be sent, the specific email campaign based on, which segment they fall into. That's generally the approach that's taken. So yeah, you can either leverage it from a strategic perspective, or it'll be implemented into the warehouse on the back end. The models will run, and everything will essentially be automated.
All right, so we've been talking about this the whole time. Have purpose with whatever data project that you pulled into or initiate. We had the exact same example. Look at this, this is cool what I found. What are you gonna do with it? Not sure yet. That kind of response. So, leverage that community of interest, folks in different departments. You have somebody with a psychology or an IO psychology degree to help you think about the people aspect of it, and layering that people data into your projects. That's always, I think, a good idea, and I'm not just biased, but I think the fact that he has that IO background and the data science background, that he's been as successful as he is because of those pieces. Along to it, I'm trying to learn the data science piece now. So, but yes, it's the bottom line of today's discussion was have a purpose, and hopefully that's what you were getting from it. Anything else, Dan?
No, I think that's it.